Hello students, welcome back to Programming in C. Myself Sreekanth. So in the previous sessions we discussed in detail about what is computer, characteristics of computer, classifications, types, generations, and also we discussed peripheral devices, various input devices and output devices. So today we are discussing very interesting topic called memory in computer. Okay, so still we are in computer fundamentals, but the agenda of this session is what we are discussing about computer memory and its uses and suitable examples. So you're all familiar about memory, right? See what exactly a memory, how it helps in computer. See, memory is the storage area of computer. Okay, what is memory here? Memory is the storage area of a computer where all the inputs are stored before processing and the outputs are stored after processing of inputs. So in computer, you want to do any operation, any kind of operation, that data or instructions must be stored somewhere. See that area we can call storage area or memory area. See the data and instructions generally we pass with the help of what input to devices we had discussed in the previous sessions. Okay, see that are entered into the computer by using the input to devices. Several input to devices we had discussed in the previous sessions. Okay, coming to the intermediary results during processing and final results after processing also need to be stored in the computer memory. See, each and every operation, like before processing, after processing, or any kind of calculations, everything is done with the help of what storage area. So without a storage, very difficult to perform any kind of operation in the computer. That's what memory takes very vital role in what computer. Okay, see computer memory basically provides what space for what storing of the data and instructions, like before processing or during processing and after processing. Okay, simply remember it, the memory is going to be enables what some storage or space for what storing data and instructions before processing, during processing and after processing. As we discussed, before processing we are giving data as an instruction to the computer with the help of several input devices. The CPU, central processing unit, processor is responsible to process it, right? During processing also requires space. After that, after completion of processing, we may get what some output or information. See that also need to store some area or some space. That area we can call what memory. Okay, as there can be many input devices attached with the computer. As we discussed, several input devices we may connect with what computer. All these devices may supply input at a time, but CPU may not to be able to process all the inputs in one go, correct? Then a place is required to queue up these inputs and then process them one by one. Even you are connecting all the inputs at a time, but CPU required to process one by one or not, then until that should be placed somewhere. Okay, and that to be queue up that devices to process them one by one. All these inputs are queued up in the memory. The same case in there with the output produced by the CPU. If the output device is busy in producing an output, the other outputs are queued up in the memory. Okay, see storage device is a hardware component capable of what holding information either temporarily or permanently. See, you need to remember these points for what computer memory. What is memory? Why required to store a memory? The data and instructions stored into the memory. Simply remember, the computer memory provides what space for what storing of the data and instructions before processing, during processing and after processing. Okay, so not only this, we can also manage several input devices and output devices also required for what space. Okay, it helps to process what? Processor to process those devices. Okay. Storage device is what? A hardware component capable of what? Holding information either temporarily or permanently. So you need to remember these points, very very important. Coming to in detail some characteristics of memory systems, right? Storage capacity, access time, cost per bit of storage, volatile, location like CPU registers, internal memory or main memory, external memory or secondary memory, some different types of access modes like sequential, random, direct. We'll discuss in detail one by one. See, what exactly I told memory is what? One of the main components of the computer system, which is used to for what? Store the data and instructions for processing. Okay, so it is actually a storage area within the computer where all the inputs are stored before processing and the outputs are stored after processing. Okay, simply you can remember before processing, during processing, and after processing we required one space or area that is called memory. See, coming to the storage capacity, you're all familiar in the, suppose you are following my videos, in the previous session videos I explained in detail about what? Memory units. Okay, that comes under what? Storage. See, what is this storage capacity? Storage capacity refers to the amount of data that can be stored in the memory. See, how we store generally? Yeah, in the previous session we discussed, right, in detail. Yeah, in computer the memory is going to be, memory units are going to be measured in the form of what? Bit. Okay, bit is nothing but what? Short for what? Binary digit is the smallest memory unit used for what? Information storage in computer. See, in previous videos I explained in detail about what is bit, how to calculate this bit. 2 to the power of x equals to y, like 2 to the power of 0, 2 to the power of 1, 2 to the power of 2, 2 to the power of 3, like 0 bit, 1 bit, 2 bit, 3 bit, 4 bit, like I explained in detail about what? 10 bits memory representations, like 16 bit, 32 bit, for 64 bit we can able to calculate it, different types of memory representation. But remember, bit is nothing but what? Smallest memory unit used for what? Information storage in what? Computer. Okay, a bit is represented by always 0 or 1. Only a bit can be represented by either 0 or 1. Sometimes we may also call value like a true or false, sometimes expressed as on or off. A single bit can hold only one of two values, either 0 or 1 value. See, I already explained bit. Okay, what is bit? Just only explained about bit. Bit is the smallest memory unit. It's going to be represented what? Either zeros or ones. Okay, right. How it represent? Small b. Shorthand is represented by small b. The capacity is what? Either store we can 0 or 1 or on or off. The 4 bits combination is called one nibble. Right? See, it is a combination of what? 0 zeros. So see, I try to draw. Previously I explained, but anyhow, once again I try to draw. This 4-bit combination in between what? 4 zeros and 4 ones. So this combination is called what? 4-bit representations. Okay. If you require in detail, just go through the previous videos. Otherwise, I attach some link in the description box. Okay. Just check it out. See, this 4-bit represents what? One nibble. Similarly, 8 bits represents what? 1 byte of memory. 8 bits represents what? 1 byte of memory. The shorthand is represented by what? Capital B. Okay, it represented by what? Capital B. See, if you go with the 1024 bytes represents what? 1 kilobyte. Okay, it represents represented by what? KB, capital. 1024 kilobytes represents what? Megabyte. 1 megabyte. Okay, represented by MB, capital MB. 1024 megabytes represents what? 1 gigabyte. Okay, it is represented by what? Shorthand GB, capital GB. 1024 GB like represent what? 1 terabytes. Okay, 1 TB. 1024 terabytes represents what? 1 petabyte represented by what? PB. 1024 petabytes represents what? 1 hexabyte. Okay, it represented by EB, capital EB. 1024 hexabytes represents what? 1 zettabyte, ZB. 1024 zettabytes represents what? 1 yottabyte. Okay, represented by what? YB. See, this is about memory units. Okay, in this way the memory we can able to store data and instructions into the computer, like before processing, during processing, and after processing. Okay, if you require much clarity regarding these memory units, already explained in detail in the previous video session, kindly check it out the previous session videos. Okay, but here it is enough. Bit represents what? The short for binary digit is the smallest memory unit used for what? Information storage in computer. Generally it represented by what? Zeros or ones, on or off. So this is about what? Storage capacity. Okay, this is the main characteristics of the memory system. Next, access time. See, this access time refers it it refers to time required to locate and retrieve stored data from the storage unit in response of a program instruction. The primary storage units have faster access time as compared to what? Secondary storage units. Okay, access time is going to be increases. Okay, yeah, in this diagram we can able to see here access time from register is low. If you go with the magnetic tape, more access time. The CPU want to access the data from different memory storage devices. Okay, the lowest access time is what? Register is. It takes more access time is what? Magnetic tape. Okay, right. Next, cost per bit of storage. See, it refers to cost of a storage unit for a given storage capacity. The primary storage units have what? Higher cost per bits as compared to what? Secondary storage. See, coming to the cost also, here this takes what? More cost, but it takes what? Low cost. See, here I'm talking about what? Cost of storage unit. I'm taking about what? Not purchasing of devices. I'm talking about cost of storage unit for a given storage capacity. Here it takes more cost, but here it takes what? Less cost. Next, volatile. See, this volatile, it refers to the loss of stored data when power is what? Turn off or interrupted. The primary storage units are what? Volatile. Volatile is nothing but what? Temporary. Okay, as the data stored or lost when the power is what? Turned off. Some storages have volatile in memory because once power is off, the data is going to be permanently is going to be off. We cannot fetch that data. Okay, to overcome that problem, we are using some non-volatile memory storages also. We'll discuss in the next coming slides. Okay, non-volatile as the data is retained even when the power is turned off. Non-volatile is a permanent memory. Simply you can remember. Volatile is what? Temporary memory. When power is turned off, data stored or lost permanently. Okay, so this is about volatile and non-volatile. Next, location. The characteristics deals with the location, like external or internal of the memory device in the computer system. See, there are different possible locations like CPU. This is often in the form of what? CPU registers and a small amount of cache. Okay, the CPU registers, it consists what? Small amount of what? Cache. Internal or main memory. This is a main memory like RAM, random access memory, ROM, read-only memory. The CPU can directly access the main memory. Okay, simply remember RAM, random access memory, is behaves like what? Main memory. That is comes under what? Location, from where it going to be CPU is going to be accessing and processing it. Next, external or secondary memory. See, it comprises of what? Secondary storage devices like external disk like hard disk, magnetic tapes, like that. These are all comes under what? External memory. We may get or access the data from what? External area. See, coming to the access modes, sequential, random, and direct access. See, what access it is, just only explain. It refers to the way the data are accessed from the memory, because who should process this data? This data is processed by what? Processor. From where it going to be processed? From the memory. How much time it going to be accessed from the CPU to the memory? See that measured by what? Access mode. Sequentially, the location of the memory is accessed in a predefined sequential order. Sequential means what? Continuous order. Okay. Random, the location of the memory is accessed what? In any order. We cannot predict. The memory can access what? Randomly, in a random ordered. Next, direct. The location of the memory is accessed what? Neither in a random nor in a sequential, but using what? Combination of what? Both modes is called what? A direct access, either sequentially or randomly. Okay, so this is the introduction about what is memory, what are the various characteristics of memory system. You need to remember different storage capacity based on the memory units, access time, cost per bit of storage, volatile and non-volatile, temporary memories and permanent memories. Locations, it's going to be stored in different locations like CPU registers, caches, internal or main memories, external or secondary memories. Some access modes like sequential order, random order or direct order. See, here you need to remember memory is nothing but what? Storage area of computer, where all the like before processing, okay, dual like processing it, after processing, entire that instructions are stored one area space. That area is called what? Memories. Okay. See, this point you need to remember about what is memory. Okay. I hope everyone is clear, right? Before processing, during processing and after processing, that data is going to be stored in one area is called what? Memory area in the computer. That measured in what? Storage capacities. Different storage capacities like bits, bytes, kilobytes, megabytes, gigabytes, terabytes, petabytes, exabyte, zettabyte and yottabytes. But smallest memory storage area is what? Bit, represented by 0 or 1. The largest byte at present, largest byte is what? Yottabyte. Okay, 1024 zettabytes represents 1 yottabyte. Okay, that's it. Coming to the memory hierarchy. The memory unit is an essential component in any digital computer, especially like personal computer systems. Okay, hierarchy memory structure consisting of what? Main memory, cache memory, and secondary memories. Okay, see, here I written some registers. These registers are small kind of memories are going to be allocated in what? CPU. Okay, see, this is directly attached to the motherboard, these registers. Okay, generally it represents what? Bytes. It can capable of storing what? In the form of bytes. Simply we can also call registers also called what? Internal memories. See, the register lie with the processor itself, hence is the closest to the processor and works the fastest. But the number of registers that can be included in a processor are limited because it would lead to increase in processor size, increases in what? Manufacturing cost. Thus the register memory is restricted to what? Minimal. So just only I told processor want to execute one job, okay, but where the data and instructions that should be stored one space, right? Yes, for small kind of immediate, okay, small kind of instructions are going to be stored in what? Registers. The CPU happily and directly interact with the register and process the data and instructions. Access time is what? Very low because it is nearest to the CPU processor. It nearest to the processor. That's what access time is what? Low. But if you go with the high level storages like next level caches, main memories, magnetic disk, magnetic tape, it takes more access time. Then obviously the performance is going to be degrades of the processor. Okay. When it is nearest for access time, the performance is going to be increases. Remember it. Okay. So this is what telling here. The main memory occupies a central position by being able to communicate directly with the CPU and with the auxiliary or secondary memory device through an IO processors, input output processor. CPU logic is usually faster than the main memory access time. The processing speed is what? Limited according to the speed of main memory. A special very high speed memory called what? Cache. The high speed memory is what? Cache is used to increase the speed of processing by making current programs and data available to the CPU at a rapid rate. The cache is used for what? Storing segment of programs currently being executed in the CPU and temporary data frequently needed in the present calculations. See, this memory hierarchy gives a relationship between what? Speed, size and cost. Remember, this complete memory hierarchy is going to be represented by what? Speed, size and cost with respect to what? Distance from the CPU. The memory hierarchy system consists all storage devices, okay, like, but you need to remember about what? Cost, capacity and access time. This is the main three categories. See, relationship between these two, what? Greater capacity, smaller cost per bit. Greater capacity, greater access time. Smaller access time, greater cost per bit. Okay, you need to remember it, these things. See, don't get confused here. I am clearly telling about what memory is, a one storage area. Okay, in memory what we are storing, like before processing, while processing and after process data that going to be stored into the memory, correct? Who should access and interact these? Processor. Okay, processor want to access this memory, interact with this memory for performing or executing some operations and jobs within the processor. Okay, then how much time it takes? Register takes very low time, but coming to the magnetic tapes, it keep on increases the access time. Okay, yeah, capacity is what? Register stores only less low capacity, like in the form of bytes only, but coming to what? Magnetic tape, it going to be stores what? Highest capacity. I told you, right? Petabytes, hexabyte, like that. It going to be store what? Highest bytes. Okay, that much of knowledge is enough here. Yeah, I told you about what is register here. Say register lie with the processor itself. Hence, it is the closest to the processor. Registers are very close to the processor and works the fastest because access time is very low. Processor directly communicate with the register first because access time is low and it's going to be executing the job. But the in case number of registers that can be included in a processor, obviously what happens here, it's going to be lead to increases the processor size, increases the manufacturing cost. That's what they are going to be only placing limited registers only. They cannot put large registers. If you are placing more registers, it's going to be increasing what? Processor size and manufacturing cost. Okay, but they have some limited registers. It helps to access time, low access time to perform particular job of the processor. Next, cache memory. See, this is a level below the register in the cache memory. The cache memory works at a very fast speed, but is also extremely expensive as compared to what? Other memories. The high cost is one of the major restrictions why we can not use lots of cache in a computer, even though it is faster. Okay, see, the next level is what? Cache. Here generally what we are going to be store, cache registers both are internal memories. It is nearest to what? CPU, central processing unit. Register stores data in the form of bytes, but coming to cache, the data stores in the form of what? SRAM, static RAM. Cache we can also call what? Static RAM. It is in the form of kilobytes and megabytes. Okay, data can store in a cache in the form of what? Kilobytes or maximum megabytes. Next, main memory. See, the next level of memory is what? RAM, random access memory. And main memory is also called what? RAM, RAM, random access memory. Here I try to write. Okay, RAM, random access memory. See, coming to cache, we can also call it is what? SRAM, but not required. Just I try to write some kilobytes, maximum megabytes we can store in a cache memory. In registers, just we can store only in the form of what? Bytes only. Okay, yes, we can store in the form of bytes. Cache we can store up to kilobytes, megabytes. Coming to main memory, we can store here GB, correct or not? Okay, gigabytes and MB or megabytes and gigabytes, because some RAMs are available 512 MB, some RAMs are available in the market in the form of 1 GB, 2 GB, 4 GB, 8 GB RAMs. Okay, is that is nothing but what? Main memory. Okay, see, this main memory is nothing but what? Next level of memory of the RAM. Basically stores all the data and programs that are computer needs while it is running. Remember, whatever the program we are written, first where it stores in the form of what? Main memory. Okay, the data and programs that our computer needs while it is running. It is fast in its operation, but slower than what? Cache and less expensive. Okay, see, comparatively these cache and registers, main memory is what? Slow. uh, Slow process, because registers cache very nearest to the CPU, it has what? Low access time, it going to be gives high performance. Okay, the higher than RAM, faster in the system. But again, price is a main limiting factor with the regards the how much RAM can be included into the computer. Okay, yeah, I can give one best example, but at present I won't give. But in the next sessions, I will provide the best example how it functioning, how it working, how this processor is going to be working. I give a best example. You may understood very clearly. Okay, but here just remember it. Here main memory is nothing but RAM, random access memory. It has a capacity to store what? Up to MBs and GB, but still performance wise compared to cache and registers is low, but whatever the data and instructions we are going to be written, that stores in what? Main memory only. Next, coming to what? Secondary memories like magnetic disk. Okay, sometimes we can call it is auxiliary or secondary memory. All the memories until the level of RAM are volatile. See, up to here the data is going to be stored in the registers or cache or main memory. Simply we can call it is volatile memory. It's nothing but what? Temporary memory. Simply you can remember whatever the data presented here, up to here it is what? Temporary memory. Once power is off or system is crash due to some problem, whatever the data stored in this area, that data is going to be vanish, the data is going to be lost. Okay, that's what we call it is volatile memory. They lose the data stored in them as soon as power is switched off. Is not a very desirable property, as you would lose all your work, because we are putting all the efforts to store data, right? But once the data is stored up to in the main memory, the power is off or any crashes occurs, the data is going to be lost permanently. That's what we can call it is volatile memory. But coming to these two areas like magnetic disks, magnetic tapes, and so on, here whatever the data here you are going to be storing, that is going to be what? Permanent memory, also called what? Non-volatile memory. So generally these secondary memories like magnetic disk, magnetic tape, optical disk, these are all the suitable examples about what? Secondary storage devices. Okay, coming to magnetic disk, you're all familiar. In the market, it is available what? GBs, like gigabytes, terabytes. Okay, best example, hard disk you can take. Yes, there you can store up to what? GBs, terabytes. Okay, in the petabytes, exabytes, zettabytes also. So here, especially in the magnetic types, highest storage area like a petabyte, hexabyte, this much of memory we can able to store here. So this is the memory hierarchy. See how this processor is going to be interacting. For registers is the lowest memory we can able to store, but it is nearest to the what? Processor. First CPU is going to look out these registers executing the instructions, utilizes the memory and executes the instructions. But generally we can store up to what? In the form of bytes. But coming to the cache, next level, it can store up to kilobytes, maximum megabytes. But coming to main memory, it can store what? MBs and GB, megabytes and gigabytes. Generally we may call RAM, random access memories, is based like what? Main memories. Okay, but it is what? Volatile in nature. Okay, your main memory consists several things are there: RAM, ROM, cache, virtual also comes, but here you need to remember the main points. Okay, but whatever the data stores in this area, the data is going to be lost in case of power is off or any kind of crashes. Okay, due to that problem, that's what we can call it is temporary memory or volatile memory. Okay, so coming to here, magnetic disk, magnetic tape, it can store huge volume of data in the form of gigabytes, terabytes, petabytes, and exabytes. So this is called non-volatile memory. Even power is off, whatever problem is come, no issue. The data is securely stored in what? Secondary storage devices like a hard disk, CDs, DVDs, pen drives, flash drives, and so on. Okay. So this is about memory hierarchy. Okay. Fine. See, we discussed in detail memory units. Yes, I would like to just explaining these memory, computer memory, and I will stop the session up to here. See, the computer memory basically categorized by what? Primary storage, another called secondary storage. In the primary storage, RAM, ROM, cache, virtual are the primary storage memories. RAM is nothing but random access memory. Is furtherly divided again what? SRAM and DRAM. Static RAM. DRAM means what? Dynamic RAM. See, coming to the ROM is again categorized by what? PROM, EPROM, and EEPROM. PROM stands for Programmable Read-Only Memory. EPROM stands for Erasable Programmable Read-Only Memory. EEPROM stands for Electrically Erasable Programmable Read-Only Memory. Don't worry, we'll discuss in detail all these things in the next coming sessions. Coming to secondary storage, again categorized by what? Magnetic disk, optical storage, another called what? Solid state storage. See, these magnetic tape, magnetic disk, cartridge tape, zip drives, these are all comes under what? Magnetic only. See, I mentioned here magnetic tape and magnetic disk. Generally floppy disk and a hard disk. Okay. See, several things are there like cartridge tapes are there, zip drives, these are all also comes under what? Magnetic disk only. Coming to the optical disk, see, like a CD ROM, like a warm drive, CDR, CDRW. Next, DVD ROM. See, CD is nothing but what here? Like compact disk. Okay. CDR recordable, CDRW compact disk rewritable. Okay. DVD ROM, DVD nothing but what? Digital versatile disk or digital video disk. See, DVD ROM read only memory. See, solid states like flash drive, pen drives, memories, cards like SD card, MMC. You're all familiar, right? SD cards is nothing but what? Secure digital cards. MMC is what? Multimedia memory cards. Yes, we'll discuss in detail in these computer memories one by one in the next coming sessions. I hope you're all clear about in this session what is memory. Okay, because of time deficiency, I try to be continue these memories in the next coming sessions. Okay, what is memory? Memory is a storage area. The main characteristics of memory is like storage capacity, access time, cost per bit of storage, volatile and non-volatile, location wise, CPU registers, internal or main memory, external memory, access modes like sequential, random, and direct. Okay, see, this is about complete memory hierarchy, how processor is going to be interacting with this memory hierarchy, which one makes more low access time with high performance, more access time with low performance, capacity, storage wise, which one is low capacity, which one is what? High capacity. Okay, see, cost wise is also there, cost wise is going to be increases, here it going to be decreases. Yes, yeah, we'll stop up to here, guys. Okay, yeah, thank you so much for watching my videos. Okay, I will continue these memories in detail in the next sessions. Okay, thank you all, thank you so much.